All right, welcome back, ladies and gentlemen. Today we're going to talk real briefly about wave behaviors. All right, now we're going to talk about 4 different wave behaviors. All right, this is what happens, the behavior of a wave when it approaches a new medium, which is happening all the time, and there's multiple of them all over the place. I'm sitting in my kitchen right now, lights coming through the window, it's passing through the glass of the window. That's called refraction. All right. I am sitting at the kitchen table, which is a black table. That light is being absorbed by the black glass. I also have here one of the reasons why I can see the plate next to me. It's a light blue plate where I had my sandwich. Is because the light waves are bouncing off of that, reflecting and hitting me in the eye. When it comes to sound waves, my kids who are just around the corner can hear me just fine because not only are the sound waves reflecting off the walls, but it is also diffracting around the corner. And these are some of the ones we're going to be talking about here. I'm going to go kind of quickly because some of this terminology you already did in the previous activity. This is just to kind of quickly recap it. All right, so I'm going to use this simulation here. All right, and so the nice thing about this first simulation here is it shows both reflection and refraction. So I'll talk about both of them here. Excuse me. So we have light reflection here. We have a surface, a light coming across here. The nice thing about this is I can change this here. All right. So one thing that you should notice as I'm doing this is about how the other waves reflect. So this top half here is we have a wave traveling. All right. It's just not going to let me do this today. I'm not going to be able to write on the screen. So I'm just going to do the best I can. All right, you see that the light wave is traveling up against in the air, which you see in the material on the right, and it hits the water and is bouncing off. All right, you notice that as it's bouncing off, all right, no matter where I move this, it seems to be bouncing off at the same angle that I started it at. All right. So if I shoot it kind of at this angle right here, it bounces off at the kind of a similar angle. Anyone who's ever played pool before understands this concept here. All right. This is called the law of reflection. The law of reflection says the angle in is going to be equal to the angle out. So we have our starting beam of light, which we call the incident wave. And then we have the bouncing off wave, which we call the reflected wave. All right. And then you see that dotted line there. Now, this is something unusual. This is something called the normal. In science, we use the word for the normal is to reference a invisible line that is perpendicular, right angle to a surface. So this is an imaginary line that is at a right angle to the surface. And the angle between the starting ray, the incident wave, and the normal is going to be always equal to the reflected angle, which is between the normal and the reflected wave. Those are always going to be equal. So that's what happens when waves bounce off. Now, when waves go into an object, when they change mediums or change materials, this one, the air is going from air into water. Notice that the wave changes direction. And that's because the wave actually changes its speed. All right, when it changes its speed, it changes its direction. All right, and so this is called refraction. All right, now we have an angle. We still have an incident wave, an incident angle, but this time we have the angle that's going down into the water. That's called the refracted wave. And then there's an angle between the refracted wave and the normal, and that is called the refracted angle. There is no law of refraction. All right. There's something called Snell's law that does some fancy math to determine those angles, but we're not going to do that here today. All right. So we have either the wave bounces off, reflects, the wave goes through and changes direction. That's refraction. All right. Then we have something that's a little bit more complicated here. This is something called diffraction. This is what happens when a wave hits a boundary, and sometimes it will bounce off, but some parts of the wave will bounce off, and some of it will go around it. So we have a wave here that's hitting it, and you notice that the wave doesn't just go straight through the opening, right? That it almost kind of curves outward around it. So if I have my barrier, right, and the wave's coming up, it kind of starts to go around it a little bit. You can see just above the opening. Sorry, I can't write on here. right above the opening, you can see where it kind of bends around the opening. This is called diffraction. This is how we're able to get megaphones to kind of project our sound outward. All right. So that is diffraction, when waves kind of go around a surface or an edge. All right. And then finally, we have wave absorption, which is one that you guys are pretty familiar with because we've already talked about this. All right, different materials absorb different amounts of light, not just based on color, but also material as well. Some are very good materials that are keeping and trapping in that energy. That's our absorption, is when energy is taken into a material, absorbed into it. It's hard not to use the word absorb and absorption. Black will absorb more, but also heavier materials. In the video they talked about how, one way to kind of help sound kind of traveling from outside is to have heavy curtains and having carpet, right? You can tell that pretty easily because if you live on a 2-story floor or have neighbors above you, like, you can hear footsteps on hardwood a lot easier than on carpet. On carpet, some of that sound wave is absorbed into the carpet. All right. Now, in the case of like light waves and heat waves, thermal energy, black absorbs it while white reflects it. All right. So absorption is just about the taking in of that energy that's being carried by the waves. So it's the 4 types of wave behavior, and rarely do you ever just get one. It's waves bouncing off, reflecting, and being absorbed, and maybe being diffracted as well. But just identifying the the 4 different types from the different types of diagrams and some of that terminology when it comes to like the angle of incident and the angle of reflection. All right. So I know that was kind of quick because I'm just kind of going over them pretty quickly. Make sure you understand what the diagrams are and some of that terminology is. If you don't, go back, look over it again, and otherwise, good luck, and may the science be with you.